Okay, so you sent over some stuff about web scraping, and you wanted to really, get into it, huh?
Yeah, I mean, I think it's one of those things that a lot of people hear about but don't always fully grasp, you know?
For sure. So for everyone listening, we're going to try to break it down, web scraping, what it is, how it works, and why it even matters.
Sounds good to me.
So at its most basic, what is web scraping? Like, how would you explain it to someone who's never heard of it before?
Web scraping is basically a way to automatically grab data from websites. Think of it like this: the internet is this massive library filled with tons of information, but it's not always organized the way you need it.
Right, like you can't just download everything in a nice spreadsheet.
Exactly. So web scraping lets you create these little bots, essentially, that go to those websites, read the information, and then pull out the specific pieces you're looking for.
Okay, so it's like having a little robot assistant doing all the tedious copy and pasting for you.
Yeah, exactly. And in today's world where we're just swimming in data, it's become super important for things like data science, market research, even just understanding what your competitors are doing.
Makes sense. So before we get too deep, let's clear up some terminology because I think there's often some confusion. We hear data scraping, web scraping, and screen scraping thrown around. Are those all the same thing?
Not exactly. Data scraping is kind of the umbrella term for extracting data from anywhere. Web scraping specifically refers to getting that data from websites, while screen scraping is a bit more old school, where you're basically grabbing data from what's visually displayed on a screen, often from older systems that don't have a way to access the data directly.
Gotcha. So for our deep dive here, we're focusing on web scraping, pulling data from those websites we all know and love. So how does that actually happen? Like, what are the steps involved in getting data from a website to, say, my computer where I can actually use it?
It's usually a multi-step process. First, your computer, or, well, the program you're using, sends a request to the website's server. It's kind of like saying, hey, can I see this web page?
Like knocking on the website's door.
Yeah, exactly. And then, if the website is cool with it, the server sends back the raw code for that page, which is usually in HTML.
HTML hypertext markup language, the
Mm,
stuff that websites are built with, right?
right. So you have this raw HTML, but it's not very useful in that form. It's
Yeah.
like having all the ingredients for a cake just dumped in a bowl. You need a recipe to actually make it into something edible. And that's where parsing comes in.
Parsing.
Yeah, it's one of the most important steps. Parsing is basically taking that raw HTML and transforming it into a structured format that a computer can easily understand and navigate. It's like organizing all those cake ingredients into separate balls and listing them in the order you need them.
So it's like creating a blueprint of the website.
Exactly. And once you have that blueprint, you can easily pinpoint the specific data you want and extract it. After that, there's usually some cleaning up and organizing involved, things like formatting dates, fixing any errors, making sure everything is consistent. And then finally, you store that data somewhere, maybe in a database or a spreadsheet, so you can actually use it.
So parsing is key because it takes that messy HTML and makes it into something manageable. Without it, we'd be stuck with this huge blob of code that we can't do much with.
Exactly. It turns that jumbled code into something that our scraping tools can actually work with so we can extract the specific data we need.
Okay, that makes sense. Now let's get into the actual techniques for doing this scraping. What are the main approaches?
Well, the main ways to think about it are parsing HTML and XML, which are the languages websites are built on. Then there's using APIs, which are sort of like direct data feeds from websites. And then techniques for dealing with dynamic content, which is stuff that loads after the initial page loads. We can start with parsing HTML. That's kind of the foundation.
Sounds good. So when we're parsing HTML, what are the different methods we can use?
There are four main techniques that are often talked about: regular expressions, CSS selectors, XPath, and DOM parsing.
Let's start with regular expressions. I know those are super powerful for finding patterns in text.
Yeah.
How do they apply to web scraping and HTML?
Yeah, so with regular expressions or regex, you're basically defining patterns to search for within the HTML code of a website. If you're using Python, there's a module called regex that's built for this. So you'd first get the HTML from the website, maybe using a library for that. Then you'd create this regex pattern that describes what you're looking for, specific HTML tags, pieces of text within those tags, things like that. And then you use a function to find all the instances where your pattern matches something in the HTML, and you get back a list of those matches.
So like a targeted search through the code. Can you give us a quick example of how that might look in practice?
Sure. Imagine you want to grab all the main headings, the H1 tags from a web page. You could use a pattern like rh1.h1. The H1 and H1 parts are literally the tags you're searching for, and that in the middle is a wildcard that says capture anything in between.
So you get back a list of all the text that was inside those H1 tags on the page.
Exactly. And there are ways to make those patterns even more specific, to really zero in on what you need. And you can even prepare these patterns beforehand, especially if you're using the same ones a lot.
Cool. But I've heard that using regex for more complex HTML can be tricky. Why is that?
Right. So basic HTML structure is pretty straightforward, but websites can get really complex with lots of nested elements and attributes. Regular expressions don't really understand that hierarchy. They just treat HTML as a big string of text. So as the HTML gets more complicated, your regex patterns can become really hard to write and maintain.
So they can break easily if the website changes its structure even a little bit.
Exactly. That's why for anything beyond very simple stuff, it's generally better to use dedicated HTML parsers, which are designed to understand how HTML is structured.
All right, that makes sense. So regex for quick grabs, parsers for the heavier lifting. What's next?
CSS selectors. Have you ever messed around with styling websites?
A little bit, yeah. Enough to know it's not my forte.
Well, CSS selectors are a way to target specific parts of a web page based on their HTML tags, their IDs, their classes, and they can be really useful for scraping because they let you pinpoint the exact elements you want. Plus, they're usually much simpler to use than regex and less likely to break if a website makes small changes.
So like a more targeted and robust way to grab things. Can you give us an example of how you might use a CSS selector for scraping?
Sure, imagine you're on an e-commerce site, and each product has a little box around it with a class name like product card. Inside that box is the product's name, maybe in an H3 tag, and a link to the product's page, which is a tag. Using CSS selectors, you could specifically grab the URL of that product page, which is the href attribute of a tag from all those product boxes.
And that's something you could do really efficiently with CSS selectors.
Exactly. There's a handy Python library called Parsel that makes working with CSS selectors super easy.
Much cleaner than trying to wrangle a complex regular expression, I bet. Now, what about XPath? I know that's something used a lot with XML. How does that play into scraping?
XPath stands for XML Path Language, and it's a really powerful way to query XML documents, but it works great with HTML too because, in a way, HTML is a form of XML. With XPath, you can get super specific with your selections. You can target elements based on their position in the document, their attributes, the text they contain. Gives you a lot of flexibility.
It sounds like it's all about giving precise instructions to find the data you want.
Exactly. Think of it like giving directions like, go to the third house on the left, then look for the red door. You can even create XPath expressions that say, find all the links that contain the word discount, or find the paragraph that comes after the image with this specific ID.
So when would I choose XPath over CSS selectors?
XPath is usually the go-to when you need that extra level of precision, or when the HTML structure is a bit more complex or inconsistent. CSS selectors are great for straightforward layouts, but XPath gives you more tools for handling those trickier situations.
Okay, that makes sense. Regex for simple stuff, CSS selectors for most cases, and XPath when you need surgical precision. What about DOM parsing? What's that all about?
DOM parsing is a bit different. Instead of using patterns or selectors, it actually analyzes the entire HTML document as a tree-like structure. It's called the Document Object Model, or DOM. Every element in the HTML becomes a node in this tree, and you can use programming to walk through this tree, examining each element and extracting data based on how those elements are related to each other.
So it's like exploring a family tree of the web page.
Yeah, that's a great analogy, and there are some really popular libraries for doing this. In Python, there's Beautiful Soup and LXML. In Java, there's JSoup.
Tell me about Beautiful Soup. That one always comes up in conversations about scraping.
Beautiful Soup is great because it's very user-friendly. Even if the HTML you're working with is a bit messy, it creates this navigable tree from the document, handles different character encodings, and provides a lot of convenient functions for searching and extracting data. You can do things like find to get the first element that matches your criteria, or findle to get all of them. With Beautiful Soup, you usually need to tell it which parser backend to use, like html.parser, which comes built in with Python, or the LXML parser, which is usually faster.
You mentioned LXML as a parser backend for Beautiful Soup.
Yeah.
But it's also a library on its own, right?
Exactly. LXML itself is another really powerful parsing library, and it's often the preferred choice when speed is critical or when you're dealing with really complex HTML or XML. It has great support for both HTML and XML, as well as for using XPath expressions if you need that level of detail.
And what about JSoup? That one's for Java, right?
Right. JSoup is a Java library that provides very similar capabilities to Beautiful Soup. It lets you parse HTML, navigate the DOM, use CSS selectors, and even work with XPath. It's a solid choice for Java developers who need to scrape websites.
So DOM parsing gives you a lot of control and is very reliable, especially for poorly structured HTML.
Yeah, it's like having a map of the entire website and being able to walk along any path you choose, picking up information as you go.
Okay, we've covered HTML parsing pretty thoroughly. Now, what about XML?
XML extensible markup language is another data format we often encounter online, particularly for things like RSS feeds and sitemaps. The principles of parsing XML are pretty similar to HTML.
So can we use the same DOM parsing approach with XML?
Absolutely. DOM parsing, where you load the entire XML document into memory, works well for smaller XML files and when you need to jump around in the document a lot.
And what about for larger files?
For really big XML files, we often use something called SAX parsing, which stands for Simple API for XML. It's a more event-driven approach where you process the XML sequentially, element by element, without loading the whole thing into memory at once.
That sounds more memory efficient.
Exactly. It's especially helpful when dealing with massive XML files that might take up too much memory if you tried to load them all at once.
And I assume Python has libraries for both DOM and SAX parsing of XML.
Yep, Python's got you covered there. XML.etree. Elementary is a built-in, lightweight library that's good for general XML parsing using the DOM approach. Then for high-performance scenarios, or if you want to use XPath, LXML is again a great choice. And if you're really worried about memory and you're working with huge files, the XML.sax module provides sax parsing capabilities.
So we have a lot of options for parsing HTML and XML, but you mentioned another major approach using APIs. Can you tell us more about that?
Yeah, APIs, application programming interfaces, are a fantastic way to get data when websites offer them. Instead of trying to scrape data from the visual presentation of a web page, you're directly requesting data from a service the website provides. And that data usually comes back in a really nice structured format like JSON or XML, which is way easier to work with.
It sounds like you're cutting out the middleman, going straight to the source of the data.
Exactly. It's much cleaner, more efficient, and generally more reliable than scraping the HTML because APIs are specifically designed for data exchange.
So what are the main advantages of using APIs for scraping compared to, say, parsing HTML?
Well, first off, the data is already structured, so you don't have to do all that parsing work. Second, APIs are usually faster because you're not dealing with the overhead of loading and parsing the entire HTML. And they tend to be more reliable because the structure of the data is usually well-defined and less likely to change unexpectedly.
But I guess the downside is that not all websites offer APIs, right?
Yeah, that's true. And even when they do, you often need some kind of authorization to use them, like an API key or special login credentials, because they don't want just anyone accessing their data.
Makes sense. So assuming we have access to an API, how does the whole process of using it for scraping typically work?
It usually follows a request-response pattern. Your program sends a specific request to the API server saying, hey, I want this data, and including any necessary details like search terms, date ranges, or anything else the API needs to know.
Like placing an order for data.
Pretty much. And then the API takes your request, processes it, and sends back the data you asked for in that nice structured format.
Are there any best practices we should keep in mind when working with APIs for scraping?
Definitely. It's really important to respect the API's rules, especially when it comes to rate limits, which are like speed limits that prevent you from overloading their servers with too many requests. You don't want to get banned for being too greedy.
So pace yourself, basically.
Exactly. And using caching, which is like saving data you've already downloaded so you don't have to ask for it again, can help a lot with that. It's also a good idea to keep an eye on the API's documentation because things can change and you don't want your code to suddenly stop working. And of course, always have solid error handling in your code to deal with any unexpected hiccups.
Now, I've heard people talk about proxy APIs and web scraping APIs. What's the distinction there?
Good question. Proxy APIs are mostly focused on routing your requests through different IP addresses. It's like wearing a disguise on the internet so websites don't always know it's you making all those requests.
To avoid getting blocked, basically.
Exactly. Web scraping APIs, on the other hand, are more comprehensive. They often include proxy features, but also have built-in tools for actually extracting the data. They handle things like parsing HTML, dealing with dynamic content, and managing cookies and sessions.
So it's like a one-stop shop for web scraping needs.
Pretty much. If you don't want to build and maintain all the scraping infrastructure yourself, these APIs can be a really convenient option.
Okay, all that makes sense. Now let's talk about one of the tougher aspects of scraping, dealing with dynamic content. A lot of websites these days load content using JavaScript after the initial page load. So how do our scrapers handle that?
Yeah, that's where things get more tricky. Traditional scrapers that just grab the initial HTML often miss out on a lot of content that's loaded dynamically.
Right, because it's not there yet when the scraper first looks.
Exactly, so we have to get a bit more creative. The main techniques for handling this involve using headless browsers and intercepting AJAX requests.
Headless browsers, what are those?
They're basically web browsers that run in the background without a visual interface. Tools like Selenium, Puppeteer, and Playwright fall into this category. They can simulate how a real user would interact with a website, including executing JavaScript, and then give you access to the fully loaded content, including all that dynamic stuff.
So it's like having a ghost browsing the website for you.
Yep, that's a good way to put it. They can click on things, fill out forms, scroll the page, all the things a human user would do, but automatically.
And that helps us get the content that would normally only load after the user does certain things.
Exactly. Selenium, for example, is great for automating all sorts of browser actions. Puppeteer, developed by Google, is really good for controlling Chrome or Chromium browsers, both with and without a visual interface. And Playwright, which is from Microsoft, has the advantage of working with multiple browsers, including Chrome, Firefox, and Safari.
Pretty powerful stuff.
Mm.
And the other method you mentioned was intercepting AJAX requests. What's that all about?
So a lot of websites use this technology called AJX to load content in the background without having to reload the entire page.
Like when you scroll down a social media feed and new posts just keep appearing.
Exactly. If you can figure out which AJX requests are being made to load that content, often by using the developer tools in your web browser or specialized software, you can actually replicate those requests in your scraping script.
So you're basically cutting out the middleman again, talking directly to the server to get the data you need.
That's the idea. And the nice thing is that the data that comes back from those AJAX requests is usually in a structured format like JSON, which is really easy to work with.
Much better than trying to parse through a huge HTML document to find that one specific piece of data. Now, what about websites that spread their data across multiple pages? You know, those next page buttons you see everywhere. How do we handle that with scraping?
That's called pagination, and it's very common. If it's static pagination, where you have clear links to the next page or to specific page numbers, it's usually pretty easy to handle. Your scraper can just follow those links one after another, collecting data from each page.
But I'm guessing it's not always that simple.
Right. Some websites use dynamic pagination, where the content is loaded dynamically when you click the next button or scroll to the bottom of the page.
So how do we handle that?
In those cases, you might need to use a headless browser to simulate those clicks or scrolling actions and then scrape the content once it loads. Or you could try to figure out the AJAX requests that are being made to load that content and then make those requests directly in your code.
And what about those websites with infinite scrolling, where new content just keeps loading as you scroll down? Those seem like a scraping nightmare.
They can be tricky, for sure. You usually need to use a headless browser like Selenium or Puppeteer to simulate the scrolling. You can programmatically tell the browser to scroll down a certain amount, wait for the new content to load, and then scrape it.
And you might have to repeat that many times to get all the data you need.
Exactly. Another approach is to monitor the website's code for changes to see when new elements are being added to the page, and then scrape those elements as they appear.
Okay, that makes sense. So we've covered a lot of the technical side of how to scrape data, but let's talk a bit about strategy. When we're planning a scraping project, how do we decide what data to actually go after?
It starts with being very clear about what you're trying to achieve with the data. What problem are you trying to solve, or what questions are you trying to answer? That should guide your choice of data.
So like, if you're doing market research, you might be interested in prices, reviews, competitor information, things like that.
Exactly. Or if you're building a news aggregator, you'd probably want to grab article titles, publication dates, the body of the text, maybe information about the authors. It all depends on your specific goals.
And how important is it to choose the right sources for your data?
Oh, that's absolutely critical. You want to make sure you're getting your data from reputable sources, websites that are known for accuracy and reliability. Otherwise, your analysis could be flawed from the start. And of course, you always want to be respectful of websites' terms of service and their robots.txt file, which basically tells bots what they're allowed to do on the site.
Right. You don't want to get in trouble for scraping stuff you're not supposed to. So once we know what data we want and where to get it from, what's the next step?
Then you need to think about how much data you expect to collect, because that can impact your choices about tools and infrastructure.
So like if you're planning on scraping millions of data points, you're going to need more robust tools than if you're just grabbing a few hundred.
Exactly. For large-scale scraping, you might need to think about using cloud computing services, proxy servers to distribute your requests, and more specialized tools designed for handling massive amounts of data. And you'll need a storage solution, like a database or cloud storage, that can handle all that data.
And what about how often the data on the website changes? How does that factor into our scraping plan?
That's another important consideration. If the data is very static, meaning it doesn't change very often, you might only need to scrape it once or very infrequently. But if it's something that changes frequently, like financial data or social media feeds, you might need to scrape it much more often, maybe daily, hourly, or even in near real time.
Right. Like if you're scraping stock prices, you probably want to do that every few minutes, not just once a day.
Exactly. And for frequently changing data, a technique called incremental scraping can be really useful. It means you're only collecting the new or updated data since the last time you scraped, rather than having to rescrape the entire site every time.
So like if I'm scraping product prices from an e-commerce website, I only need to check for products whose prices have changed since my last scrape.
Exactly. That saves a lot of time and resources. And regardless of how often you're scraping, it's crucial to keep an eye on the target websites to see if they've made any changes to their structure or content, because those changes can break your scraper.
Okay, all of that makes sense. Now, let's dive into the actual tools we use for scraping. You mentioned a bunch of different libraries and tools. Can we kind of break down some of the main ones, maybe by programming language?
Absolutely. Python is super popular for web scraping. It has a really rich ecosystem of libraries that make it easy to do pretty much anything you need.
Awesome. So let's start with Python. What are some of the go-to libraries there?
One that we talked about already is Beautiful Soup. It's great for beginners because it's fairly easy to learn, but it's also powerful enough to handle a wide range of tasks.
Yeah, it's really good for parsing HTML and XML, navigating the structure of web pages, and handling different character encodings.
Exactly. It's a great all-around tool for smaller to medium-sized scraping projects. Then there's Scrapey, which is a more advanced framework designed for building what are called web crawlers. Those are programs that can systematically browse through websites and follow links to collect data.
So Scrapey is for when you're getting serious about scraping.
Pretty much. It has a lot of built-in features for handling things like making requests, processing responses, following links, storing data, and even dealing with issues like rate limiting and proxies.
Sounds like it has a lot of bells and whistles.
It does. It can be a bit more complex to set up, but it's super powerful for large-scale projects. Then there's Selenium, which, as we discussed, is primarily for automating web browsers, but it's also really useful for scraping websites that rely heavily on JavaScript to load their content.
Because it can actually interact with the web page like a real user would, right?
Exactly. And it's a really versatile tool. You can use it to click on things, fill out forms, scroll the page, all the things a real user would do, but automatically.
So if you need to scrape data that only appears after you interact with the page in certain ways, Selenium is often the way to go.
Exactly. And then there's Playwright, which is another browser automation library that's become really popular in recent years.
What's special about Playwright?
One of the big advantages of Playwright is that it can control multiple different browsers, Chromium, Firefox, and WebKit, whereas most other tools are focused on just one.
Ah, so that makes it more versatile if you need to make sure your scraper works across different browsers.
Exactly. And it's known for being very fast and efficient, which is important when you're dealing with lots of data.
Okay, so those are some of the heavy hitters in the Python world. What about JavaScript? Any good tools there?
Definitely. JavaScript, especially with Node.js, is another popular language for web scraping. Puppeteer, which we mentioned earlier, was actually developed by Google and is specifically designed for controlling Chrome or Firefox browsers.
Right, so it's great for scraping single-page applications and for doing things like testing user interfaces, which often involve a lot of JavaScript.
Exactly. And Playwright also has a JavaScript version, so you get that cross-browser support there as well. If you need to parse HTML and XML, Cheerio is a popular choice in the Node.js world. It's a really fast and lightweight library that's based on jQuery, which is widely used for web development.
So it's like a mini jQuery for scraping.
Yeah, exactly. It's perfect when you don't need all the bells and whistles of a full browser automation tool, but just need to quickly parse some HTML or XML.
Great. And for those of us who might be more familiar with Java,
Java has some good options too. JSoup is a really nice library for parsing HTML and XML. It's very easy to use and provides a lot of convenient functions for navigating the document structure, using CSS selectors, and even working with XGlath if you need to get really specific.
so it's like the beautiful soup of the Java world.
Yeah, that's a good way to put it. And of course, Selenium also has bindings for Java. So if you need to automate browsers for scraping dynamic content, you can definitely do that with Java.
Awesome. Now, this might be a silly question, but what about those of us who aren't programmers? Are we just out of luck when it comes to web scraping?
Not at all. There are some really great no-code tools out there that make web scraping accessible to just about anyone. Tools like Octoparse, ParseHub, and Apify have visual interfaces where you can basically point and click to tell the tool what data you want to extract.
So you don't need to know any programming languages to use them.
Nope, they handle all the technical stuff in the background. You just tell them what you want and they go and get it for you.
That's amazing. So there's really a tool out there for every need and skill level. How do we even begin to choose which one is right for us?
It really depends on a few factors: how comfortable you are with programming, how complex the website you're targeting is, how much data you need to collect, and your budget. If you're not a programmer, the no-code tools are definitely the way to go. They're super user-friendly and can handle a lot of common scraping tasks.
And if you are comfortable with coding,
Then Python and JavaScript offer a lot of flexibility and power. Python has a huge and active community and tons of libraries to choose from. JavaScript is really good for scraping websites that are very interactive and rely heavily on JavaScript. And if you need to scrape a lot of data really quickly and you have some budget to work with, the web scraping APIs can be a great option.
okay, so we've talked about how to get data from websites, but once we have that data, it's not always ready to use, right? What does the data cleaning process usually involve?
That's right. Data cleaning is super important. If you're planning on using your data for any kind of serious analysis, you need to make sure it's accurate and consistent. So data cleaning typically involves handling missing values, identifying and removing duplicates, correcting any inconsistencies, and then transforming the data into a more usable format.
Let's start with missing values. Why do we get them, and what can we do about them?
Missing values can happen for all sorts of reasons. Maybe the information just wasn't available on the website, or maybe there was an error during the scraping process.
So it's like having gaps in your data.
Exactly. And those gaps can mess up your analysis if you're not careful. There are a few ways to deal with them. One is to just get rid of any rows or columns that have too many missing values, but you have to be careful not to throw away important data. Another option is to try to fill in those missing values using some kind of reasonable guess that's called imputation.
Like if you have a column for product prices, and some products are missing prices, you might fill in those missing prices with the average price of similar products.
Exactly. Or if you have data that's ordered by time, you might fill in missing values based on the values that came before or after. And sometimes the best thing to do is just to flag the missing values so you know they're there and can account for them in your analysis.
Okay, makes sense. What about duplicate data? I assume that's another common problem.
Definitely. Duplicates happen all the time, and they can really skew your analysis.
So it's important to find them and get rid of them.
Exactly. There are tools and techniques for identifying both exact duplicates, where every piece of data in a row is identical to another row, and near duplicates where there might be slight differences.
Like maybe a slight variation in the spelling of a product name.
Exactly. And libraries like Pandas and Python have some really convenient functions for finding and removing duplicates.
Great. And what about inconsistencies in the data?
Inconsistencies are another big one. You might have dates written in different formats, prices in different currencies, text with different capitalizations, things like that.
And those inconsistencies can really mess things up if you're trying to do any kind of automated analysis.
Absolutely. So a big part of data cleaning is about standardizing everything, converting dates to a consistent format, making sure all the prices are in the same currency, and so on.
So it's all about making the data as clean and uniform as possible.
Exactly. That way, you can be confident that your analysis is based on accurate and consistent data.
Okay, so we've cleaned up our data, dealt with missing values, duplicates, inconsistencies. What's the final step?
The final step is usually to transform the data into a format that's easier to work with for whatever you're trying to do.
So that might involve restructuring tables, creating new columns based on existing data, calculating aggregates like sums or averages, things like that.
Exactly. And again, tools like pandas make it really easy to do these kinds of data manipulations.
This is all super helpful. Now, I know we've already covered a lot of ground, but I'm curious about some of the more advanced scraping techniques. What do we do when we run into websites that are really trying to prevent scraping or that have super complex dynamic content?
Yeah, sometimes you have to get a bit more creative. Dealing with CAPTCHAs and rate limiting are too big.